When we do chemical reactions, it's impossible to collect 100% of the product that we calculate we should be able to make based on the balanced reaction and the amount of starting material that we start with. This is because we invariably lose some of our product to sticking to the walls of the beaker, to not complete reaction occurring in solution. All kinds of things can happen that lead us to not get 100% efficiency or 100% of the product that we expect to make. And so we can define something called the percent yield, which tells us the percentage of the total amount we could have made that we actually recover from that reaction. So let's see how this works by working an example. Let's say that I start with 10 milliliters of 0.2 molar calcium chloride solution and 10 milliliters of 0.5 molar sodium carbonate solution. And when I put those together, I get a precipitation reaction that precipitates calcium carbonate, which is insoluble. And so I collect that solid, I dry it, and I weigh it, and I find out that I have an actual yield. I have actually collected 0.15 grams of the solid. So what I want to know is, what is my percent yield? And to do that, to figure out my percent yield, I'm going to have to figure out what my calculated yield or my theoretical yield is. How much could I possibly have made if I started with this amount of material? So the first thing we have to do is a limiting reagent problem to figure out how much calcium carbonate I could possibly have made from this amount of starting material. And the way to start that is always to calculate the number of moles that I have available in my starting materials. And so I can see that because I have volumes and concentrations, that I'm going to take concentration times volume to give me number of moles. And 10 milliliters is 0.01 liters times 0.2 molar is going to give me 0.002 moles of the calcium chloride. And I can do a similar thing with sodium carbonate, and so I have 0.005 moles of the sodium carbonate. The next thing is to calculate equivalence so that I can see which one is limiting. And in this case, I've given us an easy problem to do because we have a 1-to-1 stoichiometry, and so the equivalents are the same as the number of moles. So I just divide the number of moles by the stoichiometric coefficient, but since that stoichiometric coefficient is 1 in both cases, my equivalents are equal to my number of moles. So that means that the one with the least number of equivalents, which is calcium chloride, turns out to be my limiting reagent. And so calcium chloride is my limiting reagent. And so I'm going to base my yield, my amount of calcium carbonate that I could possibly make, the total amount I could possibly make from this number of moles of calcium chloride and sodium carbonate, I'm going to base that on my limiting reagent. And so one of these makes one of these. So if I have 0.002 moles of this, that means that I can make 0.002 moles of the calcium carbonate. Now it turns out that calcium carbonate has a molar mass of 100 grams per mole. And so if I want to figure out the number of grams I could make, I remember that molar mass is equal to the mass divided by the number of moles. And so the mass is the molar mass times the number of moles will give me the mass of calcium carbonate that I would be able to make. So if it's 100 grams per mole and I've made 0.002 moles, I take 100 times 0.002. It's equivalent to moving the decimal place 2 places. And so I should be able to make 0.2 grams of the calcium carbonate. So my calculated yield, or sometimes this is called a theoretical yield, it's the amount that I could calculate that I should be able to make. Theoretical yield is 0.2 grams, but I only actually collected 0.15 gram. And so what I want to know is what percentage of the total that I could have made did I actually collect? So what part of the total amount that I could have made did I collect? And so my percent yield is going to be my actual yield divided by my theoretical or my calculated yield times 100%. And so I will find that I got a 75% yield. And so this reaction was 75% efficient.